Hey, everybody. Welcome to another JetBrains webinar. I am particularly excited about this topic today. And I'm really thankful for the folks who are joining us today. Today's topic is about OpenTelemetry and how you can free your services from vendor lock-in using OpenTelemetry. So before we get started, let me do some housekeeping here. If you're watching us live right now on YouTube, you should see a live chat happening somewhere on the screen there. Feel free to talk to people in the chat. Feel free to talk to us. If you have any particular questions, leave them in the chat, and we'll try to ask our guests those questions in order of relevancy. A big question that normally comes up, is this video recorded? Yes, it will be recorded. It's on YouTube. So please don't ask that question. But if you do ask that question, yes, the answer is it is recorded. So short of that, let's welcome our guest today from Honeycomb.io. We have Vera Reynolds and Philip Carter. So, hey, folks. How are you folks doing today?
It's who's going to unmute first game.
Yeah. How are you folks doing? Please feel free to introduce yourselves for folks who don't know who you are, and tell them a little about yourselves.
Hello, I'm Vera Reynolds. I am a senior engineer at Honeycomb on the telemetry team. So it's kind of an abstract word, but what it means is that we handle all the integrations and libraries that generate data on customers' applications and send it over to Honeycomb, which is a observability platform. And I've been here at Honeycomb for about a year. And before that, I was just a generalist. Kali was just asking me earlier what I've done in the past. And I was like, that's a really long list, a lot of stuff.
Yeah, I mean, it's interesting. Like the longer your career goes, the more you run into things and just try new things. So it's being a generalist is not a bad thing. It's actually a very good thing. So
I hope so, or I've made a big mistake.
I'd like to think it's a good thing.
Yeah, Philip, tell everybody a little about yourself.
Cool. Hey, everyone. My name is Philip, and I'm a senior product manager at Honeycomb, focusing on all things developer experience, which I like to think of as like the interface with the product, getting data in and getting data out, telemetry, getting data in, and trying to make that as good of an experience as possible, and then getting data out with like APIs and making sure that you can like automate certain things with the product. So that's my core set of responsibilities right now. And prior to this, I spent about 6 years at Microsoft working on the .NET team from the early days of like before .NET Core 1.0 and kind of helping get that up off the ground, and owning a variety of things like the F# language and language design, language tooling, and project integration tooling for Visual Studio. So all pretty much developer tools, developer experience focused the whole way, but now in a totally different environment, covering totally different things.
Yeah, I mean, I'm a big fan of F#, so thank you for the work you've done on F#, and I'm sure the rest of the community is really thankful for that. And the thing I'm interested in seeing today, which we've kind of talked behind the scenes, is how OpenTelemetry has kind of been put into the latest version of .NET. So without getting into spoilers, maybe now's a good time to kind of give you folks the stage. I'll be generally quiet, looking at the chat and gathering questions from the audience. So I'll be quiet and I'll give you folks the stage now. So thank you again.
Thank you. All right, so I think I'll start off a little bit, just talking a little bit about observability and like instrumentation and sort of why these two things matter. This is sort of like the context for OpenTelemetry, because you shouldn't just use OpenTelemetry without knowing why you're going to use it. Cover a little bit about what OpenTelemetry is and a little bit of a deep dive into some of the components of it, And then I'll switch over. We will switch over, and Vera will cover how you actually use it with a fantastic demo, and hopefully you'll be able to take away sort of a general strategy for how you would adopt it yourself, and an interesting way that it can integrate with the backend observability developer tool. So, instrumenting for observability is something that you gotta do. I should caveat that if you're working in services, which is a ton of developers these days, so that's a pretty decent statement to make. If you're doing mobile development or desktop development that's talking to a backend, arguably you should care about this too, but it's going to be more of a concern today, at least if you're on the backend or like on the full stack interacting with your services. So you may have heard the phrase observability before. There's a bit of a thing going on in industry right now called observability washing, where like every single vendor that has ever done anything at all with logs or metrics or traces will say that they are also doing observability. Jury's out for a lot of them. We at Honeycomb like to think that we're one of the few who actually are doing observability right, because it's not like there's a big focus in industry right now about like talking about the data types. Oh, observability is like this thing called the traces, the metrics, and the logs. I'm like, yes, these are data types that matter, and I'll get to that. But that's just a means to an end. What you really care about are a set of outcomes, and you care about how you achieve those outcomes. So every developer wants a predictable release cycle. You want to have operational resilience. You want your tech debt to be managed. You want to be able to make it so that your systems can generate at least enough data so you can get insight into what the heck your users are actually doing with your systems. And of course, you want quality code. Like these are all outcomes that I think pretty much every developer would like to achieve. And like it's kind of like a virtuous cycle, right? Like if you have operational resilience, you can achieve predictable releases. But if you don't have one of these things, it's kind of hard to get the others, right? Like if your tech debt is not managed, then your operational resilience could probably suffer, and so on. And this is really, really hard in a services world where you have dozens, potentially hundreds of services all talking to each other, doing all sorts of weird things, and people talking to different parts of those services in weird ways. And like, you can't just like load up a debugger and just step through the stuff there. I mean, like there's some ways you can kind of hack it today with some like snapshot debugging things where you need to make sure the version of your source code is exactly the same as the version of the thing that happened to be deployed at the right time. And like, that's never actually true. So like, how do you figure out what the hell is going on? Well, you do what's called instrumentation. And instrumenting your services is generating useful info about how it is being used. And then you store that in some sort of data store. And there's a lot of choices out there. Honeycomb is one tool that offers that. And then you query that data to ask interesting questions, right? And these questions are not simple questions, right? Like it's really easy to know if something is down. Like you can set up a quick dashboard to be like, oh, service A is down. All right, cool. But like, why though? What led to it being down? That's where observability sort of gets there. It allows you to ask questions like, what were the characteristics about certain database queries that timed out at 500 milliseconds? Like, what do they share in common? Are there different service versions that are similar with respect to like what you might be seeing? Are there browser plugins involved in cases? And then in their cases where there's no browser plugins, is that not sharing those same characteristics? There's also this question of like, do you know if your systems are healthy, what that should generally look like? Right? It's not just about understanding what went wrong. It's like, okay, well, I can generate a query that shows me some information in a time series, and I know that means my system is healthy. Are you actually confident in that? That's sort of where observability is getting there. And so if you want to understand these kinds of things, you need to produce data with instrumentation, and then you query that data to answer your questions. And so what data is involved? This is where that thing that I mentioned earlier, or this thing that if you Google observability, you'll easily run into a thing that's saying that's about distributed traces, metrics, and logs. this is your means to achieving observability. And I really want to highlight distributed tracing above the other two. A lot of developers are probably familiar with logging. You logged somewhere that something went wrong, perhaps, or that there's some information about something, and that's still useful, especially for detailed debugging info. A lot of SREs are probably familiar with metrics, where you get some aggregated summary statistics. Like there can be like system metrics, like CPU and memory utilization of a system versus some, like, for example, if you're running in Java, like you get some JVM specific metrics about like a system and that kind of stuff. But distributed tracing is the important stuff, because this is more at the application level than anything else, right? And specifically, it's sort of, you could think of it like logs with causality. And so you know that if there was an issue from service A talking to service B, talking to service C, that then talked to the database, you can trace that entire thing. And distributed, meaning that, those services can be located pretty much anywhere else. And like, it doesn't matter where they're actually located. They don't have to live within the same node, within the same cluster, within the same data center even. And so like that's sort of the key to understanding what's actually going on. And so you can sort of turn any kind of structured data into these things. That's kind of an abstract thing, but as you'll see in the demo today, it's actually quite easy to generate a trace and then see what's happening with it. And that's where OpenTelemetry comes in, right? You're like, all right, cool, I get it, Philip. I'm all on board with distributed tracing. Well, what do I do? Well, you adopt OpenTelemetry. Don't adopt a vendor-specific stuff. Adopt OpenTelemetry. So let's talk about what that is. It's also called OTel for short. So if you hear me say OTel, if you hear Vera say OTel, that's what we're referring to. There was a previous project called OpenTracing that has been folded into OpenTelemetry, and it used to be shortened to OT. And sometimes you will see people say OT refer to OpenTelemetry. They know what they're talking about. Just assume they mean OpenTelemetry. Okay, so OpenTelemetry is vendor neutral instrumentation, right? So prior to OpenTelemetry and OpenTracing and this other project called OpenCensus, if you wanted to understand more about your systems, you had to pick a vendor, and then you had to instrument with their vendor specific libraries that had proprietary ways to generate traces and generate metadata about traces. And like, that's cool and all, but what if that vendor stops being useful to you anymore? Or like, maybe it is useful, but your organization has decided because of a sales deal or whatever, you're going to move to a different vendor. A lot of times you don't control that stuff. Well, shit. Now, as a developer, you have to rewrite all of that code, because the vendor-specific stuff is not going to work for the other vendor-specific stuff unless they happen to be nice enough to generate some sort of like little exporter for all the other vendors out there. And like, they tend not to do that because that's a ton of work, and like, it's no good. And the thing with this kind of instrumentation, like code level instrumentation about what's going on in your system, should not belong to any specific vendor. This should be open. You should be able to use it anywhere you like, and you should be able to choose a tool based off of how useful it is to you and your organization, not because you're locked in and therefore you have to stay with it, because otherwise it's going to be too expensive to move off of it. So that's my whole soapbox spiel. That's why OpenTelemetry exists. So it replaces the need for those vendor-specific SDKs, and it comes with, it's a framework. So it comes with the ability to do tracing, this thing called context propagation, we'll talk about a little bit later, metrics, and soon logs. And it even goes into this thing called automatic instrumentation. So like if you're using a popular library for networking or something like that, you could just load in a component that will automatically instrument everything about using that library rather than having to write that code yourself. Even though it is vendor neutral, it's not like in opposition to the other vendors. Like a bunch of vendors in this space, including Honeycomb, contribute to this project because we recognize the importance of what it represents, and we want to make sure that we all have the best possible support for it. So it's got a few components. There's a spec, straightforward. It has a thing called the OTel Collector. which is a Swiss Army knife proxy that's really powerful, especially if you come from more of an SRE background. Talk about that a little bit more. There's per language APIs and SDKs. And there's auto instrumentation libraries for frameworks and libraries for those specific languages. So there's a lot there. This is where it kind of sits in that previous diagram. So the overlap is intentional, that it's kind of a little bit in the data thingy there, but basically this is where OpenTelemetry fits in this whole picture. So it's very important, but you'll notice it's not encompassing the whole thing, because OpenTelemetry is your means to an end. What you don't like, you should care about the actions, but you ultimately care about the outcomes. Those are the things you want to achieve. We believe that OpenTelemetry is the best way to achieve those. And so you should be able to achieve that, or rather you can today, regardless of whatever language or tech you use, right? There's SDKs for Java, .NET, Node, Python, Go, Rust. There's even a PHP one building up. I think it's like in pre-alpha right now, but like this, if you use a language, there's a pretty good chance you can use OpenTelemetry and have a good time. So let's talk some nuts and bolts about some of these components. Because I said a bunch of words, but I didn't really define what they actually were. So APIs, specifically, it's data types for everything tracing, metrics, and logging, and methods or functions, depending on what your preferred terminology is, for getting that data from your code, right? So like this is just some quick sample C# code where you could use OpenTelemetry trace. You create this thing called a tracer. That's like this concept in the API, and then that tracer allows you to create a thing called and that tracer lives like at the application like process level, and then you can like generate traces from that tracer. A trace from that tracer, and then you can start what's called a span. So a trace is a collection of these things called spans. It's literally, as you would expect, a trace of what happened in your application and the various steps along the way. And then spans are these logical groupings that represent operations. So like you could imagine if you have a controller that gets some information from a user, you could have a span that represents the work that was done in that controller. And then maybe that calls another method. And then maybe you want to instrument that method, and that could have another span, and that span could be a child of the previous span. So you know that they're logically grouped that way. And so you can set metadata on them, like these things called attributes, and then it's pretty straightforward there. A big concept is called context propagation, right? This is what makes it distributed. Right. So everything that I've talked about so far is probably pretty easy to understand in the context of a single machine. But if you have two services running in different data centers, how do you get a trace that covers both of them? Well, the distributed context is how. It's this abstract data type that's basically just a set of key value pairs that are associated with a trace. And it contains metadata about like trace ID, the span ID, and allows like when you create like a new span, for example, it can say, okay, well, regardless of where this thing started, I know the IDs and I can link them all up. And so then when you go back and you store that information and you query it, your observability tool can understand that they're actually linked together. And so that's in the case of everything except for Golang, for some weird reason, this is going to be automatically serialized and propagated across process boundaries for you. So it's not something that you have to like turn on if you're in like Java or .NET or something like that. You could choose to turn it off, I guess, but most people aren't going to want that. And then it uses a format called W3C trace context. You can also use a different format called B3 that's a little bit more compatible, but if you do that, you then need to configure every single instance to use a different format. Like most people just use the standard trace context metadata. You could conceivably load in a different one if you like, but I'm not aware of anyone doing that so far. So key bit of distributed tracing that OpenTelemetry offers for you and sort of makes it as automatic as possible. Speaking of automatic, there's automatic instrumentation. So this is just wrappers around frameworks and libraries that generate data. So in this case, I'm creating what's called a tracer provider. again, another API concept. And there's a little line of code that says add MySQL data instrumentation. This will wrap the wrapper around MySQL. I forget the name of the library, but it's like the standard library for interacting with MySQL in .NET. And whenever you interact with that ORM, it will generate traces for you specific to those operations that you're doing in the database. It doesn't go into the database, but it sort of like wraps the ORM part. And so then if you have a trace that interacts with that ORM, it correlates with data going in and correlates with data going out, and you don't have to write that code yourself. There's ASP.NET, for example, and .NET has that. Pretty much every single major web framework has this sort of thing where it'll automatically capture, this is like, the request and timings with that request, like status code, that sort of stuff. And a whole lot of stuff in between. Like if you use Java, there's like literally dozens and dozens of libraries available. Speaking of Java, it is one of a couple of other languages that chooses to additionally bundle this automatic instrumentation in an agent. So basically, in a lot of languages, like with .NET, for example, each automatic instrumentation component has its own library that you pull in, and you use it ad hoc, or you can use a distribution, which we'll talk about later, that pulls that in for you. Or like in the case of Java, you can just deploy an agent with your application that then turns on all the instrumentation for you. In this case, I actually have this line of code showing Honeycomb OpenTelemetry Java agent. This is, we didn't like create this whole agent concept ourselves. This is just like a wrapper around the upstream agent with some additional stuff in there, some additional config, making sure that there's a couple goodies that you can do in OpenTelemetry that are like considered optional, and we sort of enable those by default. But it's pretty straightforward, right? You just launch the jar with your app. There's a version of this for Python. There's probably going to be versions of this for other. I believe they are working on one for .NET right now. So like you have some options basically, and like you can use the option that best fits your team's preferences. So now there's SDKs, distributions, exporters, and collectors. So apologies in advance for the heavy concept count. Not expecting you to memorize this. This is all on the website OpenTelemetry.io. It's the website, and like you can read about this here. But so an SDK is pretty much what you would expect it to be. This is, it wraps the API. It does useful stuff. That's what you use. And what's interesting is vendors can create distributions of SDKs. So there's the vendor neutral SDK, like for .NET, but it's very unopinionated. And usually when something is unopinionated, that means configuration is a bit more difficult. And in this case, things like loading in automatic instrumentation is all done on like an ad hoc one-by-one basis. Vendors can do a bit more of an opinionated take on an SDK. So in our case, we like to make, clearly exporting your data to Honeycomb as easy as possible. And so we'll make sure that, like you write as little code as possible. You basically just have like your API key and, the optional endpoint or something like that. And like a concept that we have called a data set. And then you're off to the races. But then we also, we believe that you get a lot of value out of all your automatic instrumentation being turned on by default. And so we make sure that it's all in there. I think there's work that we're doing right now on the .NET one that was contributed. This is actually contributed by one of our customers to make it so you can turn off individual pieces of automatic instrumentation if you prefer. But like that flexibility is what's important there. And so if you're the kind of developer who's like, I'm fine with boilerplate and I want complete control over everything that's happening, you can use an upstream SDK and be totally happy. If you're like, hey, I want it to be a little bit easy, I'll use the vendor neutral SDK. The vendor specific SDK. And then all those do is just makes that config easier. And then everything from there is just the same APIs, right? So all of your instrumentation code is going to be the same, even if you swap vendors and swap their SDK distributions. Now, there might be a little bit more, config work when you switch vendor to vendor, like that sort of thing. But, that's, we're talking about like probably less than 1%, if even that, like a fraction of a percent of the actual code related to OpenTelemetry here. And so that's really powerful because it makes it super easy to switch. So an exporter it's in the name. It allows you to export your data from your code to a place. How they get configured, there's a couple different options. There's a protocol called OTLP, or OpenTelemetry Line Protocol, that can be represented either today as gRPC with protobuf or protobuf over HTTP, and there's an experimental JSON over HTTP format. When you configure your own exporter with an upstream SDK, you have to sort of pick which one you want, and then you have to like specify what your endpoint is, and then maybe there's some additional metadata that has to be in like header fields, like either gRPC metadata or HTTP headers. But then from there, it's fairly straightforward. You can choose something like Honeycomb or an open source backend tool like Jaeger and self-host that. Options, you can do pretty much whatever you want there. And then lastly, the collector, which I mentioned before, it's a proxy, right? It sits between your running application and your data store, and it can be configured like you can change your proxy without changing your application at all. And so it's really powerful, especially if you have someone with a bit more of an ops background who wants to tweak things. So lastly, I do want to cover a little bit about the collector because it is kind of a big deal. So I said that it's a proxy, but it's a lot more useful than just a proxy. Yes, it can act as an interface between some backend system and your applications. But one of the reasons why it was created is there's a lot of applications out there that are already instrumented. You might be using Jaeger tracing, or maybe you have something using open tracing already because you bought into open tracing back when it was started. Well, you don't want to have to rewrite all of that code just to be able to use OpenTelemetry, do you? Well, no, of course not. Like you might rewrite incrementally over time, but like you should get value out of observability in the interim. And so that's sort of the collector can play that role where it will automatically translate input formats into OTLP, or it can translate something coming in as OTLP into a different output format. Basically purpose fit for whatever tool you have there. And so there's a couple bundled that are available already. But like if you have some sort of custom tool, for some reason, you can actually write your own exporter. There's like an interface that you follow, and then you just load it up into the collector proxy itself. And then ta-da, you can export to pretty much anywhere. It's a bit more work that way, but it's flexible, and that's what matters. You can also perform sampling of your data in the collector. Sampling is a really key concept in observability when you're generating a bunch of information. You can imagine you have a whole bunch of HTTP 200s. Well, like you probably don't care about every single one of those, but you care a lot more about HTTP 500s, right? So you would weight the 500s much more heavily than the 200s. And so, the 200, you could maybe take like 1% of those values or 10%, or like, there's all kinds of strategies for sampling based off of what you can do. You can do some of that in the collector, which is really great. You can also filter spans by specific things. Like if you know that you don't care about a specific kind of span, you just filter it out altogether. You can do what's called span processing and just transform that data from one format into another and add attributes and metadata at the proxy time. Like it's totally customizable. It's a total Swiss Army knife, and you can deploy it pretty much however you like. And there's distributions everywhere. So that's what I got in terms of explaining things. And I'll hand it off to Vera, who's going to show you the cool stuff.
That was amazing. I was just so impressed by how much you were able to fit in that time frame. So we're not going to be talking about HTTP cats. I just wanted a sort of landing page that was neutral. But we'll be talking about is an example greeting service, which is just a playground application that we use in our team to experiment with stuff. And it's ridiculously over-engineered on purpose because we want to demonstrate the whole distributed tracing paradigm. So first, let me go over what an example greeting service is. The whole purpose of the app is to generate a random greeting or a random name. That is all. And it takes 4 services to do this. It is a year service that generates a random year. We have a name service that talks to that service and then gets a random name out of a matrix based on that year. There's an instance of Redis running that has some random messages in it, and then a service that talks to it. And then we have a front-end API that kind of puts it all together and returns that greeting. So let me show you what it looks like in action. I have all of my services already running in containers. So pretending here that I am the big distributed system. And I'm just going to go ahead and curl my front end. And hello, Olivia. Woo, woohoo, I guess is a greeting. Let's do it again. This is rendering a little funny, but hello, Sophia. Good day to you. Awesome. Looks random enough. And so a large part of the code is already instrumented. So I'm going to start by kind of walking through what it looks like, and then we'll add a little bit today as well, just to give it a little spice. The nice thing about having the 4 services is that we can have a few different permutations of things. For instance, we have our front end and message service that are both instrumented with the Honeycomb distribution. That's the kind of glorified wrapper that Philip was talking about. And then we have year and name service that are using the standard OpenTelemetry libraries. We also have a smattering of .NET 5 and .NET 6 because we wanted to try different things. So I'm going to focus on the year and name service because they're using the standard libraries. So let me pull that up. All right. So let's start with the name service. So that's the .NET 5 application. I'm going to start with the dependencies. Philip mentioned that the OpenTelemetry SDK for .NET specifically is kind of modular. And so you'll notice I'm importing a few different things here, like the exporter, hosting extensions, and instrumentations, which, if you remember, auto instrumentation. The way I am using them is by setting them up in my startup file. The really crux of what I'm doing is right here. I am in my services configuration method, and so I'm adding OpenTelemetry tracing. Some of this stuff is sort of implementation details, they're not very important, but I do want to highlight that adding the OTLP exporter is kind of the important glue, right? That's the part that's going to actually send it over to a backend. I happen to be using Honeycomb. It doesn't have to be, but that's what I'm familiar with. I also want to point out that I'm adding ASP.NET Core and HTTP client instrumentation. So those are both going to create, trace, and span information for me already without me lifting a finger. ASP.NET Core will instrument incoming requests. So any controllers I have will be instrumented, and then HTTP client will instrument outgoing HTTP requests. I'm not going to go over the rest of the details because I don't want to get too far in the weeds, but I do want to highlight a .NET 6 application as well. You'll see that my package references look exactly the same. The only difference is that the block of code that initializes OpenTelemetry is in the one program file now, but otherwise it looks exactly the same. And I just no longer have a controller. I just have this minimal thing, which is pretty cool. So just with that amount of code, I want to show you what it looks like in Honeycomb as an example. So I know I generated some traces earlier, but I'm just going to go ahead and hit it again a couple of times for funsies. And I'll go ahead and go to Honeycomb. So this is our UI. I'm not going to go over it too much, but hopefully it's kind of self-explanatory. I'm just looking at the number of events that were sent within the last 10 minutes. And I'm going to zoom in here. These are traces. And so I'm actually going to go ahead and look at one of them in particular. They're all going to look the same at this point. And voila, a trace. So each row here represents a span, so an operation. And I want to highlight library name. For instance, here in the front end, we have ASP.NET Core library that instrumented this span. So what this translates to is there's a greeting controller in there. Then that front end service within the greeting controller is making an HTTP GET request, which is instrumented by the HTTP instrumentation library. We'll actually have the same tool for 3 of our services because they're all making outgoing requests. And then the year service is a leaf, so it's not making an outgoing request. So this is just the controller. Oh, I'm sorry, this is the fancy new minimal API. So this is just the /year handler. Cool. So with just that block of code that I showed you in my program, and a couple dependencies, I'm already getting this much information out. Here's the Redis instrumentation too. Forgot to show that. And that one even gives me some events about when my message wasn't queued, how much time has passed, and when I received the response since my span was started. So it's really powerful. And I do want to point out that this is just the beginning. We're really hopeful that the more people use it and the more people contribute to it, the more instrumentations we'll get. So if you have like a really obscure like message system that's not Redis or something common, like there's a really high possibility that it's actually going to be instrumented for you. Cool stuff. So with that, let's go ahead and try to add some of our own manual instrumentation, because we at Honeycomb believe that that's kind of like where the rubber meets the road, right? You're the one who knows your application best. And so the auto instrumentation is wonderful, but it can only do so much, right? It doesn't know the specifics of your business. So I am here in my year service. And let's say that I happen to know that determine randomness and determine year are two important operations. So what I'm going to do is add spans around those operations. Because remember right now in our UI, I only get the one span for the year service, which is the API handler. So I'm going to go ahead and jump here into my functions and create a span around this. So I'm going to do, I cheated a little, I set up a few things beforehand, but I already have a tracer here in my program, and I just got it from the OpenTelemetry API. So I'm going to go ahead and ask my tracer to start an active span. I'm going to call this one determine randomness, I think. Yes, I'm a determine randomness, cool. And this is a closable, so I'm going to using cool, sorry. I am using an EAP release, so this might happen. So what this is going to do is going to create a span for the duration of my function. And it will make sense once we see it in the UI. But remember, we're trying to create a tree, like a trace is basically a tree. So we're going to create one here, and I'm going to go ahead and put one into determine year as well. Now I should see my container rebuild.
You're only allowed to hum royalty-free music, by the way. Just
good point. I'm assuming this is in every elevator. That was okay.
Yep.
Okay, and I'm gonna generate a few more. Okay, cool. Now let's look at some of our traces. So I'll go back here, run my query again. There's a batch of things that I just generated. Again, they should all look basically the same. So let's look at one of them. Oh, look, we have new rows here. And notice that they're both children of the greeting, I'm sorry, of the year handler, because we're doing them sequentially. Pretty cool. And what's interesting here is that if I were to look at this later, or let's say somebody else instrumented, and I'm just looking at their traces, I noticed that that year endpoint takes like over, it's kind of hard to see, over 500 milliseconds. What's up with that? And if I had done the due diligence and instrumented the sub operations of it, I can tell that, determining randomness is the big chunk of that operation. That's what takes the longest time. Curious. One more thing I want to do is add an extra attribute to an existing span. So let's say that the random number that I generate is somehow pivotal to what this year endpoint does. So I want to add that attribute to this span right here. I'm going to go ahead and show you how to do that. So here's my I. Now I want this I to exist on the span that's representing this handler. So what I can do is I can ask the tracer for a current span, and this is just going to pull it out of the context that's representing each operation. and I'm going to set attributes. And in this case, it's going to be randomness I, and wait for the rebuild again. And the reason that I wanted to show both of these is because you don't necessarily always want to create a span. Like, this is where you kind of have to blend with the auto instrumentation and decide what makes the most sense, right? Sometimes you just want to decorate things that are already there. Other times you really want to chunk it up and create more branches in your tree. I have rerun. Let's do this again. Sure, good enough. Let's take a look here. All right. Zoom in, please. Okay. So this one is at 9 because telemetry data is actually being buffered in my applications and sent over from each service. So sometimes it might take like a few seconds for them to catch up. So if I actually rerun it, you'll notice there are all 10 now. Okay, so let's see. Do I have, oh, look at that, randomness of 0. Cool. Well, how would I use this? Remember how I noticed that determining randomness is actually the longer operation under returning a year. So let's say I actually have a little more data. I want to have a bigger pool to work with. And I'm trying to simulate like production level traffic, which is kind of hard with just a single machine, but this should give me a nice batch here. I'm going to look at all of these together now. And for this experiment, I'm actually going to visualize a heat map of duration, which is going to show me the distribution of durations across my requests. And so here I'm seeing that there's a lot of them down at the bottom. A lot of them are under 150, but then there's a few up here in the 500 range. And I'm kind of like, I have a hunch that something's different about them. I don't think they're entirely random. So what I'm going to do is try to determine what is different about those. And this is something Honeycomb specific, but the point is I'm trying to work with this data to see like what's going on. And I noticed that, oh, interesting. So everything that took 500 seconds had a randomness value of 0. And everything else had a different value, like 1, 2, 3, 4 in this case. If you were an astute observer, you probably noticed that I have a random sleep in there for when I generate a value of 0. So this is sort of like a silly example to show you how powerful this data is and what you can do with it. So we covered auto instrumentation. We covered adding attributes to existing spans. We created some of our own spans. I guess maybe one last thing I want to highlight is what Philip was getting at with the vendor not being vendor locked. In my perfect world, right, I would have these manual instrumentations that are business specific to me all over my code. If I wanted to stop using Honeycomb, let's say I left Honeycomb and I was doing this webinar for another company, I would use this same example with the only difference being that I would switch my headers and my endpoint to a different backend. And that's it. And as long as the backend supports the OTLP format, I'm golden. So I think that's it for me.
Yeah, that's it's kind of amazing seeing the Honeycomb UI in terms of generating that heat map and being able to drag on the top like those top data points, right? Like that was really, really cool. And just looking at the .NET code, it's interesting because it is a lot of like ceremony up front in terms of configuration, but there really isn't a lot of code in your business functionality, right? So it is pretty awesome. It blew me away, so I'm pretty excited.
Yeah, and it's, this was a .NET flavor demo. In something like Java, for example, you will have decorators for your functions, right? That can just have like a span name here above your method. So there are some like regional differences as far as languages go, but the primary ideas are the same. The API is meant to be friendly because it's meant to kind of enable people to own this stuff. And so we hope that more people do.
Yeah, I think Philip hinted at it too. It's there is already a lot of instrumentation throughout a lot of the dependencies you pull in, especially things from Microsoft or third parties that are writing database drivers. I'm pretty sure they're already using historical tracing methods like system diagnostics trace, or even diagnostic sources that emit these events. So it's just a matter of pulling those dependencies in and maybe bridging that gap between the old ways of tracing and then translating it into, an OTel style compatible trace message, or that kind of approach. So for the most part, yes, you can instrument it. And like what you were saying, Honeycomb believes like that's where rubber meets the road, but you can get a lot out of OpenTelemetry just by pulling in dependencies that have their own tracing in them. I think that's exciting as well for a lot of people. So,
and it's a much easier lift, right? Like if all you have to do, I mean, ideally, write the agent. You just add an executable to your app and see a bunch of stuff. Like we all want that. But yeah, like it's a journey, and so you start there, and then you start leveraging the community contributions, and then eventually, maybe you'll get to the point where you write your own.
Yeah, very, very cool.
I did want to pull the curtain back a little because you had mentioned diagnostics. OpenTelemetry.net is actually very like coupled to the existing diagnostics implementation. So under the hood, it's actually using those activities and sources, and you can use that interface as well if that's what you're used to.
Yep. Yeah. The .NET team, my former team, yay, are awesome, and they have they and I believe that there's a team in the Azure organization that does a lot of the development for OpenTelemetry.net. Like they designed this whole like, hey, we already had kind of like this tracing system. How do we make this as compatible as possible with OpenTelemetry? And like behind the scenes, that's what it uses. And then there was some like tweaks done in the libraries and runtime side to make sure that like distributed context gets passed around and all that sort of stuff. So you kind of have like two options specifically on the .NET side. I personally prefer the OpenTelemetry naming conventions and stuff. It's kind of a bit of a wrapper around the system diagnostic source stuff. Just because, like if I'm working with JavaScript or another language in my code base, like then there's going to be a similar terminology across all the languages. But if I'm coming from a .NET space where I've already instrumented with system diagnostics, I can use those same nouns and verbs, and they will just work with OpenTelemetry once I pull in the packages, which is pretty amazing. Now, I mean, just work there's like some tweaks because like there's some patterns. Like you establish the diagnostic source, I believe, or no, sorry, it's the activity source is the equivalent of tracer. It's trying to keep, but like you have to like make sure that like the life cycle of that like matches the appropriate thing and stuff like that. But you don't have to throw all your code away, which is pretty awesome, I think.
Yeah, I think that's a great point because when I started looking at OpenTelemetry, I wasn't really sure like should I be using the tracer directly, or should I be using activity and accessing the activity through like the static instance of it and stuff like that. So it's great that you gave that recommendation. If you're starting greenfield, probably should just start with the OpenTelemetry interfaces, just so that you get in the habit of learning that vocabulary, right? So excellent point. I guess to get into the Q&A part of things, when I was watching Vera kind of go into Honeycomb, you can see the what, but what's the future of OpenTelemetry? What's on the roadmap? Like, is there going to be features that help people pinpoint exactly where some values are being emitted from, like specific to their code? So what's on the OTel roadmap?
I could talk a little bit about that. So OpenTelemetry fairly recently made tracing 1.0. So like, the stuff that we think is the most important, like, that's stable. You can use that. It's 1.0 across the spec, the API definitions, and, each of the SDKs, modulo a few that are still in very early, but like all the major languages have 1.0 for that. The other two signals, metrics and logs, which we have not talked about, are still in progress. Metrics has gone stable in the spec and the API level. And so now it's up to the vendor neutral SDKs to implement that. Some of them are like in beta already, and some of them are kind of still in pre-alpha. It kind of varies from language to language, but I think like in the near term, like you could expect like in the next 6 months, that's going to stabilize at the SDK level. And then the log side is still experimental, but it's kind of a high bar. Like experimental means like, yeah, you're probably not going to utilize it today, but like it's probably going to be available next year. And so then logs are where you can get a bit more detailed info. So like the way that I think of it is like tracing shows you what's going on in your application. Metrics can show you contextual information. Like you can say, oh, well, not only is there this slow operation happening as per what like a span is saying, but maybe memory and CPU utilization of the system itself that it's running on is spiking up at that same time. Or maybe there's some JVM or .NET runtime specific stuff that you want to care about. Speaking of .NET 6 added native metrics signal stuff into the runtime, and so when that lights up in the SDK for .NET for OpenTelemetry, like you can get .NET runtime level information. It's contextual. Like the two can work in concert with each other, and then logs. Part of the reason why it's experimental is it's about a very specific point in time and doing a bit of a deep dive. You could get like if you wanted to understand what the actual this is where I think some places get a little mixed around, and there's some work to do in terms of guidance. Like Vera showed that you can effectively log by setting an attribute. There's also this thing called a span event that represents an event that happens within a span. It's sort of like a pseudo log as well. But it's not like proper, like structured format log. Most people have used a logging framework of some kind. There's all kinds of really important stuff you can do with a log there, right? So like this is like a span event. So like you can care about like when things happened, but it doesn't give you like, detailed info or like call stack or like that sort of stuff. So I think there's a lot of consideration into what is going to go into the log side of things specifically. Another part of the roadmap is sampling. So we didn't cover that here, but there's two basic formats, or approaches, I should say, for sampling. What's called head sampling and tail sampling. Head sampling is saying up front, I'm only going to take some percentage of traces, and I'm going to just drop the rest. And that makes sense in a lot of cases, especially if you have really high volume. That like a percentage will still be statistically significant, and so you can just do that. Tail sampling, instead of generating the trace instead of dropping the trace completely, it will then generate like the whole thing, and then choose to sample or not based off of some decision that you may have configured. This is a much more, like the trade-off is that it's more expensive because you need to do the whole operation, then do some computation based off of values that are contained within that thing. But it allows you to do much more detailed stuff. Like you can sample based off of values of specific metadata inside of your traces and that sort of stuff. There's basic head sampling in OpenTelemetry today. There's no tail sampling at the SDK level. That's something that you could sort of expect to go there. And then we also want to refine the options for head sampling. And so this is sampling is something you go very, very deep on. And there's a lot of that going on right now. But like on the roadmap, that is certainly coming up. And then I think in general, for the OpenTelemetry project, it's just more SDKs and more stabilization of those SDKs, more automatic instrumentation across the board for every language, and then more adoption by vendors. right? So Honeycomb, we're a little bit on the earlier side. A couple of others, like Lightstep, are also on the earlier side, where like we can just accept OpenTelemetry data by default. You don't have to export it. Well, not all vendors are like that yet. Like for a lot of them, you'll have to load in a custom exporter that'll put it in a format that they can talk. Eventually, that will not be the case. OTLP will just be natively understood by pretty much every single vendor out there. And then additionally, a lot of we have an SDK distribution. You could expect other vendors to do the same, just to make sure that configuring for their backends are sort of there. So there's a lot of different pieces that are all sort of moving along. I would say the general theme is maturity. And then beyond that, who knows? Sky's the limit.
Yeah, I mean,
actually,
yeah, go ahead. Sorry, Vera, go ahead.
I just wanted to follow that thread with the aspirational vision, right? Is as far as auto instrumentation right now, it's still mostly authored by OpenTelemetry community, right? So let's say I'm as a community member will write instrumentation for the MySQL library for Node.
Mm-hmm.
I don't know how it works. Like I can look at their code and infer how it works and like guess at what should be a span and what is important. But I think like in a future, in a world where everybody adopted OpenTelemetry, those library authors can actually build that into their products so that the OpenTelemetry project itself is purely just a standard, really, right? It's a bunch of tools that enable this, but the people that are best suited to generate the data do it, whether it's you as an application owner or you as a library author.
Mm-hmm. Yeah, I mean, that to join you in the future that you described, like if you just write code and you're using a lot of these dependencies, you get a lot of information right out of the box. So it's like you only, hopefully in the future, only need to trace the things that are very, very, very specific to your application, right? And
Yeah.
I think that to me is very exciting about just the standard and its propagation throughout our ecosystem. But that brings up like an interesting other question. Both you and Philip mentioned buffering and sampling. Like, what kind of impact can folks expect to see on their code bases by having OpenTelemetry, buffering requests in memory and then making those requests to a collector, those kind of things? So what kind of impact can folks expect to see?
I smile because I know my answer is going to be it depends. So yeah,
that's always the right answer.
Yeah.
I mean, that's fine.
It's not free, right? You are in this example that we looked at today, you're adding some additional things to your code, and yes, there's like a queue in there now for your spans. Now, in most SDKs, that stuff is configurable, so you can like buff it up or down. Or do you want to make more HTTP requests, so like send smaller batches more frequently? Would you rather accumulate them and send them less frequently? But then if your app shuts down, you might lose them depending on how you handle the shutdown. So yeah, there's a lot of knobs. In our experience with customers, we haven't seen a lot of like detrimental effects on their performance. Mm-hmm. Unless there's a bug, right? Unless there's like a memory leak and something's wrong, we haven't really seen a lot of people talk about it. Now, the collector, it's a whole other beast and a whole other thing, right? It's a separate service that you have to run and tweak and like take it on. So I imagine that is more of an advanced use case. Philip, do you want to talk over it?
Yeah. I think I mean it's like any kind of performance work. So like spans themselves. If you like look under the hood and see like how they actually get encoded, it's like this very compact binary format that's like it's not human readable at all. It is they're like specific bits mean specific things. And it's very thin in that regard, and that's great. There's also like on the metric side, like counters, for example, are like very very lightweight sort of things. If you are at I think where it gets interesting is in the metadata, application level metadata that you want to append. So like appending an integer is probably not a big deal, but appending the value of a large string might actually be a big deal. And like, it kind of depends on what your use case is, right? Like if that is happening at a very, very high throughput part of your application, don't append big strings to spans because that's a lot of allocations that you don't need to do there. And like OpenTelemetry is not going to like reallocate the string 20 times or whatever, unless it's a bug and that's just going to get fixed. But like, you should be conscious of where in your application you're doing this sort of thing. And of course, if you're in a place where it's like, yeah, if I have a little bit of marginal overhead in attaching some metadata, I'll do that so I get richer information.
Mhm.
It's all a trade-off in that regard. But then also, I would also argue that if you have something that's like a very high throughput layer, that should probably be as thin as possible. You shouldn't have like this high throughput big chain of events, or you sometimes you can't avoid that, but like
Yeah.
that's just generally going to be harder to manage anyways, even without OpenTelemetry. So.
Yeah, I think most of the loggers now have analyzers around them that basically say, hey, maybe you should consider passing in string constants rather than trying to like format a bespoke string, because obviously every time you generate a string, you're generating allocations and taking up memory, and that stuff has to be collected. So it's generally good practice not to generate random messages in your logging. It just leads to disaster. So, yeah, I asked this question of you folks before, and I know a lot of our audience are building different types of applications. Like, who benefits the most from using OpenTelemetry? Is it folks building mobile applications, distributed microservices, monoliths?
Um, I think it's a bit of a mix.
Mhm.
So right now, I would say that if you're in the like distributed services world, you're probably going to get probably the most benefit right now, because you're inherently building a system that has so many different failure points that are really, really hard to diagnose.
Mhm.
And if you can't load something up on the debugger to reproduce the state that led to whatever happened, let alone even understand that state in the first place, it's table stakes. You need this stuff, because otherwise your backend is just going to be a disaster if you get enough traffic and enough
Mhm.
endpoints added to it all. On the monolith side is interesting. So as a lot of people know, if you have a full monolithic application, you can load that all up in a debugger in your IDE, and like that's a really powerful way to debug, and I think you should keep doing that. But it does not. It still doesn't capture the interaction points, right? Like there's a lot of monoliths out there, but increasingly a lot of companies that have them are creating smaller services that talk to them, and so then even if the bulk of your code is in one service, you kind of do have a distributed system of sorts, or at least a multi-service system. Maybe it's not distributed across data centers or nodes or whatever. And so in that sense, when those services interact with each other, that's important. The other thing is like tracing with causality, like that's what it is. It's adding causality to your system. Really, any system can benefit from that. Whether or not that is going to like truly unlock the insights that you need or make it as debuggable as you want it to be, I think the jury's out. For some people it will, for others it won't. But we have a customer right now who they have some services in Rust, they have services in Node.js, and they have a big .NET monolith, and they're instrumenting all of it because it's all really useful to them. And so I would that's sort of where I'd rank them all right now. And then I guess on the mobile side, there's not really any. You could probably make it work, but there's no like mobile specific SDKs right now. One
Mhm.
area that is getting some attention, which I guess I should have also called out in the roadmap for OpenTelemetry, is front end instrumentation. So like you have your I don't know, like a Next.js app or something like that. And, you have your trace of like the user interacting with the different components, and then it ultimately hits your backend. And then you get that full picture, as opposed to just knowing that a part of the backend was hit. That's something that's getting explored right now. And so in the future, I guess you could expect to see something on the mobile side, but I don't know if anybody's like started on that work. So who knows like how long that would be.
Yeah, I remember you mentioned JSON over HTTP, and I was like, oh, that's interesting, because I would immediately think that's for front end. That's for front end developers to pass that information through the entire stack. So now you have both the systems you do control and the hardware you don't control, and having all that information, that's super powerful. So I don't know if there's really any other questions that are specific. I think you folks really answered them. So this is probably a good place to kind of stop, unless you folks have any other things you'd like our audience to know.
I guess just when you were talking about the mobile stuff, it reminded me of a request we've been hearing a lot is AWS instrumentation. Like, can you just help me? I don't know what's going on here. Can you help me see what's happening there? And you know, obviously I'm not part of that group, but I do hear that AWS is like us. They're in OpenTelemetry. They're contributing. They're working on kind of embedding it in their stuff. And so I'm really excited to see some of that come to fruition, right? So like, yeah, you start in your browser, you see all that jazz, and you see all your service stuff, and then like if you're running Lambda, you see all of your Lambda execution.
Yeah, just data. We want more of it. I think that
more data.
More. So on that note, I think that's a really good place to end it. So you know, thank you folks for giving this presentation. The chat's very positive. I thought this was a great presentation. Thank you again. So let's go to my slides now, just to kind of wrap things up. If you folks are looking for more information, you can visit jetbrains.com/writer to see our IDE. You can also visit our blog, jetbrains.com/.net, to see our latest .net news. Be sure to follow us on Twitter, follow us on YouTube, like and subscribe. If you want to know more about Honeycomb IO, go to honeycomb.io. If you want to know more about OpenTelemetry, you can go to OpenTelemetry.io. Be sure to follow Philip and Vera on Twitter. They're always tweeting fun stuff about OpenTelemetry, and they're great to chat to online. So again, thanks for joining us today. It was really fun to have the folks here. And Vera, Philip, thank you again. And for the folks watching on YouTube on a later date, please be sure to subscribe, because that really helps us bring this stuff to you. So thanks again, and we'll catch you guys next time.
Thank you.
Thank you. Bye-bye.